Thanks very much for coming on, Andy, and welcome to a class act. Really excited about this one. As always, I've got Andy McMahon on, and if you're serious about building real AI capability, you always know the catch. There's a gap between AI that looks impressive and AI that actually works. This episode is about what it takes to cross it, the engineering rigour that turns a slick demo into something you can trust in the real world. My guest, Andy McMahon, went from a physics PhD to Director of AI and MLOps Engineering at Barclays. He lectures at Oxford and he's written a book on machine learning engineering with Python. We get into AI capability, where AI really breaks down at scale, and what separates the teams building things that last from the ones that stuck in the demo. Before we get into it, a quick ask: if you're watching on YouTube, hit subscribe to keep episodes like this coming. Alright, let's get started. But I was thinking, just quickly before we get started, I was actually looking back on my Meetup app there, and I can remember back in 25th of May 2017, you came and presented on smart logistics and supply chains in the 21st century. It took me right back. I think you were just kind of crashing into the scene. You'd just finished your PhD and you were really...
Yeah, that's right. I was an absolute nobody. What I remember about that one, was that the one where I think Jason Costello
It
was talking
was,
as well?
exactly. Yep,
Now,
he was...
what was amazing about that was Jason and I turned up in basically the same outfit.
That's right.
We both had the same colour of jeans, same black t-shirt, we both wore glasses.
Aye.
And it was like we were just two carbon copies of each other. It was very bizarre. I remember actually, Michael, I rocked up to you. First meetup I ever went to, I think, was one of yours. And I just rocked up to you and went, how do you speak at these things? You go, oh, you just turn up, you just tell me and I'll put you in. And then I was in the next one. I knew nothing about anything, but I gave it a go anyway, which is probably a good short history of my career. When you don't know anything about anything, just give it a go anyway.
All right, Andy, so physics PhD, particle physics research in Hamburg. How did you end up building AI systems at a bank?
Yeah, it's an interesting story. That's the particle physics thing in Hamburg. That was an undergraduate placement I did. Had a great time in Hamburg. Then did my master's and PhD in condensed matter theoretical physics, Imperial College, London, and then it transitioned into this world of AI. So I always tell this story, but it was during my PhD. Harvard Business Review had the article, Data Scientist, Sexiest Job of the 21st Century. I thought, that sounds a bit all right. What the hell is that? And then you realise that a lot of the skills they were talking about for data scientists, how to think quantitatively, how to analyse data, Python, these were all things I'd had from a PhD anyway.
Yeah.
And I thought, just personally, I really value having an impact. And I like thinking about problems. I don't like going super narrow on one specific thing. I like going deep into things, but I like going deep over a couple of things.
Yeah.
And I think just moving to industry was the right thing. So yeah, tumble through a few different roles in energy, logistics, then went into financial services. And yeah, I've ended up at Barclays. But the thing that's always driven me is that piece about how do you take sort of the systems thinking I had as a physicist and apply that to real technology problem. As I say, just trying to create real value in the world, which obviously drives you towards engineering as opposed to just pure science. So all those things have came together quite nicely, I would say.
No, definitely. I think that article's got a lot to answer for us, but even my last guest, Asia Fall, she was at Booksy, but it was physics as well. And I actually kind of read that article and ended up in at the BBC doing data science. So she just spoke about that in the last episode.
Good ROI for the article, I think,
definitely.
For the industry. Definitely shoveled a lot of people in. It's interesting because I think it was the first time we had seen stuff for physicists, for example, that wasn't saying go into quant finance.
Yeah.
That was a big thing, obviously, for years, going into Wall Street, going into the city in London and all that, and making money or kind of having a career that way. But it was just interesting to see, you can apply these skills in many other domains. And it became a really exciting time. And it's just went from strength to strength since then, I would say.
Definitely. And it's quite, you kind of look back, and I can remember I was doing data recruitment before that as well. There probably wasn't loads of places in Scotland for a data scientist to find a job like before 2015. Yeah. So a lot of talent was having to just go to London, go to Europe, and further afield as well. And like, everybody is banging on about AI agents right now. What are people actually getting wrong?
So in the world we're in now, the barrier to entry to just hack something together is so low.
Yeah.
You could fire up your browser just now, go into a few different sites, you could get Claude Code installed, and you could build like a really complex app just by prompting these models. And your app could have agents running around, it could be doing all sorts of stuff. You could set up OpenClaw, give OpenClaw access to your Outlook and your bank accounts and all that if you're feeling brave, and get it going and doing stuff. So the barrier to entry is really low. But I think a similar theme to what we saw before with, say, ML and MLOps and data science. That is different from building a production system at scale, or something that serves hundreds of thousands, millions of customers in a way that's robust and reliable, something that actually makes decisions that might have safety concerns, life or death. Stuff I did previously, say at Greco a few jobs ago, where we're actually stopping generators catching fire. So you have to take that seriously. So doing that is a different challenge from building that demo, which is even easier than ever before, but building the production system still just as hard as it was before. That's the first thing. Demos don't equal production, which has always been true, but I think now it's more stark because there's so many demos. The other thing about agents that's a kind of particular concern, I think, is that we're just naturally building systems that have complex chains of interaction. So what I mean by that is, if you build an app, if you build a traditional web app, traditional software development techniques, you predefine the execution path. So you go in, you go to the login page. It's supposed to go through a few steps, and then you basically write the programming logic to say, if this step fails, do this, etc. With agents, what you're doing is you're allowing decisions to be made by these AI models as to how it executes to solve a problem. And then what you're doing is chaining lots of these up, and you don't control in a specific sense how that gets executed. So basically, there's these complex interactions that are happening. So things can go wrong at one step in that chain, and that then propagates all the way through. So basically, if the first agent either makes a wrong decision or it's been given bad data or something, that could propagate through quite easily systems we've been building. And then I think the other thing is this is also new. In a sense, I always talk about it's an evolution, not a revolution, in the sense that traditional software engineering, traditional DevOps, traditional MLOps, all of that still stands. We're adding to it. But the way we build with these agents and what we're trying to build and go after is quite new. So people are learning as they go. They're building the plane as they fly it, was a phrase one of my bosses used to say. And I think that just means that, we don't know what we don't know until things start breaking. So we're seeing people get into production even, although that is difficult. They'll see really weird ways these things have failed. And only then they start building the testing and the evals and the monitoring that actually starts catching that. These are new ways things fail. We're writing the book and how all this gets done as we do it. So it's just all of those things together mean that it's very easy to get a few things wrong.
You've seen people going out and like building things and kind of probably not doing the proper checks and and just kind of leaving it, and it's going into kind of, I'm not, maybe no production in the industries you're in, but it's going and doing stuff. And I heard someone speak at a meet up just a couple of weeks ago, and they're saying, look, we're a few years into this, maybe 4 years. They're like, would you trust your 4-year-old just to go and run something straight away as well? And it was quite interesting. But I know what you're saying. Like, I've got friends and like people who kind of just love like jumping into things and building it. And they've talked to me a Sunday evening and said, I built a full ATS system for the business. It could do this, it could do that. It's GDPR compliant. I just rattled it out in Claude in a couple of hours. You're like, calm down. Like, I don't think we're ready
Calm down.
to go with stuff like that. But it's so accessible.
There was an amazing paper. I'll try and link it. Lemuria, I think it was, but I think they were from MIT.
Yeah.
And they've just done an analysis on looking at contributions of code on, say, GitHub for people using AI agents to code.
Yep.
And what they've found is basically just exactly what we're saying. It's like the amount of new code being generated is humongous.
Yeah.
But the amount of new things going into production or being real apps or real contributions to projects is only a little bit bigger than it was before.
Yeah.
So this huge funnel where there's a lot generated at the left-hand side, is not getting through at the right-hand side. And that's basically because generating the code wasn't the bottleneck. The bottleneck is building high quality code, high quality review, testing, validation, monitoring, observability. All of these things gradually chip away and mean that the initial kind of 300,000 lines of code you wrote, you actually only want to keep a few hundred. What they're finding is that it's just there's more on the left-hand side, but still being quite aggressively winnowed away when all these quality checks come in. So it's a super interesting time. I think we will fix and accelerate all that, but it's really interesting.
I'm jumping off topic a little bit, but it is quite worrying at times as well, because the amount of people that I talk to on like a daily basis are now like a kind of AI consultant. They're getting into businesses and advising businesses, building things for businesses, and you're like, I don't know, you've kind of been looking at this for 6 months as well. It takes time to really learn as well and put the years in that people like yourself have put in. But you've been building the plumbing that most teams skip, observability, tracing. Why does that matter so much?
Yeah, so I'll come on to what all those sort of mean. So observability generally, and tracing part of that is just generally how do you see what's going on in your system. So there's lots of traditional stuff from software development, DevOps, site reliability engineering that tells us how we can basically, you add bits to your code to basically say, tell another system what's going on in this system, and then you can go view it and you can build alerts on it. So you can do basic logging, but this is a more detailed or rich picture of it. So basically, you can see everything that's happening inside your app. And that gives you visibility into what's actually going on. So it means when things break or they're not quite working, you can really get into the depths of why without having to actually go and touch the system. You're just getting all this information about what's happening under the hood. Just exactly like when you go to the garage and someone plugs your car into the computer, they can get all the diagnostic information. So it's the exact same thing, but we should be thinking about that with our software apps. And with our AI apps, it's just that the observability we're getting is even richer. So when we talk about traces and spans, that was a concept in software development anyway. So basically, whenever an app does something, it emits a trace, which is just all the stuff that happens in that little bit of code that gets executed, all the little kind of changes and updates to data. Now with AI, that includes you calling an AI model with your prompt and getting a response and it doing reasoning and it calling tools. So it's quite rich data about what AI is doing and why it's making specific decisions. And if you're not tracking that and gathering that, you can't improve the app. Really, you're flying blind. Someone comes to your user and says, I keep asking this question and it's giving me garbage, or it's fetching information that's really out of date, or it's could even be something dumb. I'm asking it the weather and it's telling me it's raining. It's clearly not raining outside. If you can't see what's going on in the internals, you're not going to be able to improve that. Whereas if you're gathering all this information, you go, oh, there's a weird bug that means it's always hitting the weather for yesterday. Or there's a weird bug saying it's not fetching fresh data. Or there's a weird bug saying that I've prompted it a certain way inside it tells it to do something strange. So that's the first piece. The next one is kind of Eve. So this is really the extension of what testing was before. So when you test in software, there's this testing pyramid. The bottom layer is like you're just taking every individual piece of logic and saying, this thing's meant to add two numbers. So if I test it with 2 and 2, does it give me 4? If I test it with 3 and 3, does it give me 6? You then build that up and say, how do all the bits stick together? It's integration testing. If I make a change, does it perform the same as before? It's regression testing, etc. Evals in the AI context are just saying, given the core app behaves the way I expect, but does the AI piece behave the way I expect? So if I ask an AI a question, does it give me a reasonable answer? I mean, that could be really simple. If I ask it the capital of France, does it tell me Paris? It's a really simple and silly example.
Yep.
But it could actually be if I ask it to generate a complaints letter for a customer in my financial services organization, given the initial letter, you then ask it, does it follow the guidance I've given you? Does it mention the original reason that the complaint came in? Does it make sure to call the customer by name? We can give all these things
Okay.
and evaluate the performance of the AI component, and that's evals. And what that does is that just gives you the confidence that what I've built should be doing what I want it to do, so that when I deploy it, I can trust it. And all of that comes together by what we call trust infrastructure. It's basically saying that I'm as confident as I can be in this system, but I can also see what's going on, so I'll catch what goes on. So that's what that's really about. And again, that's part of the difference between building a little demo that's just for you and your mates
Yeah.
versus something in production for millions of customers in a regulated industry. Sort
Definitely.
of that trust piece
Yeah.
goes from 0 to 1.
So I think that's what gives so many people that don't really understand AI the fear as well, like trusting
Yep.
software and people to come in and build something for their business, like customers and clients and even like the stakeholders. Definitely, that's very important. And there is a view like enterprise AI is slow and cautious, while startups move fast. Is that fair?
Yes, I would say that's fair.
Mm.
But what I would phrase it as, I think everything's about trade-offs. A lot of my job is thinking about trade-offs, actually. A lot of my job is helping make design or technical decisions that are trade-offs, right? You can always optimize one thing for another. I think in this question, you're trading off two of the V's. Remember the 4 V's from big data? There's two that are velocity and veracity.
That's right.
And I think what you're doing here is you're trading off one against the other, right?
Mm-hmm.
So in a startup world or a fast-moving environment, I can optimize for velocity. It's not to say I cut corners, but it's just to say that we're time constraints, even with our agents running. You've got 5 days now working week, right? So your choice could be I ship as many features as possible and make the product as rich as possible, which is absolutely fine to optimize. But it obviously means you're spending less time battle hardening and testing to the nth degree and going through review and all of these other things. In a financial services organization or regulated industry, you're biasing more towards veracity and trading off velocity. So you're saying in the 5 days, I'd rather ship less features or one feature. I'd rather do a lot to check and validate and make sure it's compliant and make sure it follows all the rules. It's very easy to go too far the other way, where you slow down innovation. And this is where really senior technical leaders come in. Their job, I view it, is to try and help strike that balance, because organizations can't sacrifice velocity entirely. Otherwise, they'll get eaten alive by competitors, or they'll just be left behind and customers won't be happy because they'll be missing out on the experiences and products that they could otherwise have in the market. So there is a trade-off, but I think there's also missed sometimes is that trade-off sometimes does spawn innovation in its own right.
Yeah.
So a lot of the stuff that we've done in the bank, things like evals, also looking at guardrails, which is this idea of, and harnesses now, harness engineering. So this idea of how do you build the surrounding capabilities that help keep your AI system within the behavioral bounds you want to set. I don't want it to be able to talk to you about mortgage thing. So I want to put guardrails in to tell it how to behave in certain scenarios. Or if you start asking it inappropriate things or behaving inappropriately, I tell it how to respond. So guardrails as well. But a lot of that came from the fact that we have to be compliant with regulation. We have to be compliant with our own standards. We have to be compliant with our own best practices. And that's forced innovation because it meant we've invested time in those things that if the job was actually just, can we do this thing? Can we get an agent to process a XYZ in principle? That's different from doing it in practice with these guardrails on it. So it's just a different kind of balance, I think. And then the final point I would say is that you end up, I think whether you're a startup or a big enterprise, you end up having to solve the same space of problems anyway. It's just about where it comes. So like startups will eventually, once they get big enough and they have enough customers, they'll start thinking about the same things we think about from day zero.
Definitely.
Because we're starting with a huge customer base and we're in people's pockets and we have access to people's money and they trust us and that's our main brand. Whereas the startups maybe being a bit punchier and trying to grow their market size, etc. So they're just, again, it's that trade-off. Eventually they'll start thinking more about those controls and things, and we are trying to come the other way and trying to be more innovative and fast-moving. So again, it's just always about managing those trade-offs, but eventually you end up trying to solve the same set of problems. It's maybe about when it happens.
Really good points. I noticed probably just maybe 6 months ago, there was, for years, a lot of people have been talking about like guardrails and evals and maybe talking about like AI ethics stuff. Even if there was an explosion about 6 months, I had a lot of clients who were going into like regulated environments and different organisations, and they were like, "Look, we need people. I need to bring in an AI ethics list as well." And it was a tough search trying to find people who haven't just put that on their CV as a buzzword, basically, and said they're kind of an AI ethics specialist, to find people who really kind of know how to do it. And it's a lot about writing policies and procedures and getting all that. It was a fascinating world.
No, it is, and I think there's a challenge as well where you probably see this. Organizations don't know what they need yet because everything is so new. So they might say they need an AI ethics person. Maybe what they actually need is engineers who can help translate their existing compliance professionals' work into the system. Do you know what I mean? So we do a lot of work with our control partners. We work with like compliance, security, legal, and we're doing the engineering work to say, you've got these policies and things. Tell humans how to behave in the organization. Let's tell our agents how to behave in the same way, and let's put the controls in. We'll just help you select the right technology, configure that technology, but just take all your subject matter expertise and translate it across. Sometimes you need that rather than someone who is an AI, say, ethicist or something. But it's hard because some companies will call it that, but they mean another thing as well. So I don't envy your job, Michael. I think that's a particularly tough one, just where that's very hard to get right.
I've said this on numerous podcasts over the past year. It's been a real learning curve for myself. Been in data recruitment for 20 odd years. I worked on one particular search in Scotland as well, but it was usually take 48 weeks, but it was like 4 or 5 months, and it was just, I think I learned so much in that time as well, through a little bit of trial and error as well. I can put my hands up and say you need to really dig deep when a company's looking for a head of or a director of AI, what they really need and what that person looks like, and it's good times. And even with the ethics stuff, I was just by chance someone was coming out a contract that I found, but people who'd been on the market for a while were getting offered 6 figures anyway to go into consultancies at the moment, because it's the people with the skills who'd done that. But I'm interested in this question as well, because your book's getting a full rewrite towards AI engineering. What does good actually look like in 2026? This is a topic I'm here more on.
So my book now into the 3rd edition. So it's interesting. People ask me, how many books have you written? Well, like, I've written one, but I'm writing it for the 3rd time. So how do you count that?
I know.
The 2nd edition was a relatively big rewrite of the 1st. A lot more. We added like 200 pages or something. Went way more into depth. I think now I'm starting to write the book I've always wanted to write. I'm applying a lot more engineering rigor from the ground up. I think I made a few assumptions in the previous versions about who the readership was. Trying to get more data science people exposed to engineering. Now I think I'm actually going to try and write more for the engineering audience, exposing them to more AI concepts. But the other big thing, as you say, is the field's changed, right? We're not writing about MLOps anymore. I'll still have that in the book because I think it's important. I think you get a lot of hybrid systems. The machine learning, building models in the traditional sense is still going strong.
Yep.
I think that's important to say as well. But yeah, now it's really about how things have changed and what the focus is. So the big change for me in terms of ethos, MLOps was always about this core concern that everything grew out from. The sort of seed was always the model. Can I train a model using the frameworks and capabilities I've got that solves this in principle? And I prove that in some sense statistically, etc., or the data I've got. And then I had to grow a system around it. I'd put the model in a storage system, a model registry. I'd then build a pipeline that would fetch that and run inference at time. I would expose that via APIs or some other sort of architecture so that it could trigger the model at the right time. And that's what MLOps was about and all the other stuff I mentioned, observability.
Yeah.
With AI engineering, the primary concern has totally shifted because I've outsourced that model piece completely. I just trust those models out there that can solve my problem in principle.
Yep.
Anthropic, OpenAI, XAI, whoever the partners are,
Yep.
the frontier labs, Mistral, etc. I assume they've got models off the shelf I can use as a commodity. My job now is to squeeze as much value out of that in my particular context. So the concerns are different. I'm not thinking about how I grow this model and store it in model registries because the model's there. It's just sitting for me to hit an API. So what instead I do is I say, what's the system I'm actually trying to build? What's the user experience I'm trying to build? How do I feed this AI model the right information? So that's context engineering. How do I do all the stuff we've mentioned? How do I observe this properly? How do I alert and monitor on it? That's a totally different question.
Yeah.
Before, with traditional machine learning, supervised machine learning in particular was really easy to monitor because you'd be like, predict a number, forecast the market, or back to my earlier example, forecast the pressure change in this generator, whatever it is. You know pretty quickly if you're right or wrong and by how much. I predict a number, I was 5 off, so I'm 5 wrong, so I can store that and do something with it later. For a lot of this natural language stuff that's so interactive and flexible, it's much harder to define that. How do you tell the ground truth of this conversation? Say I was an AI just now. How are you evaluating how Andy's doing?
Yeah.
How are you going to alert that I'm going off piece? How are you going to define that in code or in a framework? That's more difficult. And then when you're trying to move towards really autonomous system, and I've had a lot of fun with this recently, if you're going to build a system that eventually analyzes and diagnoses, say, infrastructure platforms and actually proposes fixes, so acts like a kind of engineer, how do you build the trust that it can do it? Just back to our point before. So really the book's about moving towards that world where the primary concerns have changed, focusing on those pieces that are a bit different, and then again just really hammering down on a piece we mentioned before, which has always been the focus of my career, which is how do you cross that chasm between cool demo and actual system that's delivering value. So that's the focus. But I'm super excited. I've got the first chapter in. That's with the reviewers, the editors just now hammering through the second chapter, and I'm having lots of fun on kind of helping stuff. It's good.
When do you think it'll be out? About this year?
Yeah, hopefully tail end of this year,
Nice.
maybe early next year. Although the field's moving so fast that by
I
then
know,
we
that's-
might have to change it again.
Yeah.
Quantum engineering with Python or something. But hopefully kind of tail end of this year is the big push here at the latest, I think.
Because even when you were talking there, I was just like thinking like how things are changing so fast at the moment. And again, it's a point I go back to all the time. People like yourself who I know are top of your game and others I've spoke to and know it's just a continuous learning journey. There must be a lot of reading of papers and different things and speaking to people, and it just seems like it's never ending, which is, if that's the way you're wired, it's great as well.
I love it for that reason.
Yeah.
I think I get bored relatively easy anyway. This is great. The danger is like constant stimulation, so it's like you never turn your brain off. And I've heard the stories of people in Silicon Valley turning into vampires because they're just up coding all night because they can code with agents. But I think for me, it's like I just constantly try and review what am I getting exposed to kind of day to day, and then making sure not you plug the gaps, but you go back and tend the rest of your skill set. Like for example, I've realized that sort of I'm doing a lot of system design architecture and stuff, which is still deep technical work, but important. But in work, I'm not in the critical path for coding. So I'm just making sure I do that in my own time.
Definitely.
So it's like I've started contributing to open source again. You know, it's like last night I raised a PR on the Strands eval. It's just making sure to your point, you're just constantly checking what do I need to keep sharp, how do I keep the fundamentals layered up? And that's the other thing is like through this, the field has been changing, but the fundamentals are always there. What do you care about? You care about resiliency, you care about scale, you care about safety, you care about trust, you care about solving the actual problem and impact. The actual ways you do those things change, the actual frameworks, what you actually type on the keyboard changes, but those concerns are always there, and they always will be. And that's why I always think that way. I always try and think it's a very physics way to think about it. What's the fundamental assumptions, and build up from there.
Yeah.
So that kind of keeps me.
I just keep thinking, when people talk, I keep thinking of examples. And I was at the Data Fest a couple of weeks ago, and there was I can't remember his name, but he'd done a lot of work in Silicon Valley. I think he worked with Elon Musk and all that, and he was saying something like, my daily meeting with him was like 3:30 in the morning. It just random things he was talking about,
My
like
God.
different people in their life there, and it's just what you were talking about there, like continually coding and working and building, and everybody's saying now, all these startup founders in Silicon Valley and these builders, they're up at 5 o'clock in the morning, they're out running, they're doing their meditation, they're doing this, they're having their match. And he said, if you're a startup builder and you're an entrepreneur and you're really getting going in Silicon Valley, you're still up coding. You've not been to your bed by 5 o'clock in the morning. Never mind that. We say they're just working 24/7, wired on coffee, building.
I'm not, to be fair, I'm not that bad.
No.
For me, it's like it's a marathon, not a sprint. Or you get little sprints, basically. Someone said this to me. I can't remember where I heard it, but it was like, life comes in season. I totally buy this.
Yeah, same.
Now, sometimes the seasons are stormy and you have a lot of seasons in a year, but it's kind of, I think it's important to, like, for me personally, have a baseline that's steady, and then you can push foot in the gas when you need to.
100%.
There's a delivery or like a thing you want to build, you just hammer it for a few weeks or a month, a couple of months, and then you tail it back just to recover, and then you can go again. Where some people just like, they go at it all the time and they burn out.
It's important. No, it's important. I was just in my head.
No, but I think you're right. I think a lot of people in
Silicon
Valley and others, you hear the stories, like I was saying, the coding vampires. It's maybe not sustainable, but we'll see.
Definitely. And look, when you're looking at teams, what tells you someone's actually good that a CV won't show?
Yeah, so I think generally for me, how they reason is really important. I always hire for kind of attitude in general, a general sense of aptitude. Specific skills are important. If you need somebody to come in and hit the ground running and really start doing X, Y, Z, it's important to know what that is. But then from chatting to people, you can tell how they've internalized how things work, different from what they've maybe written. You can have conversations with people, and you, just to your point earlier, you can go, you've said you're doing these things, but really you're just not explaining to me like you get it. Or if I threw you in a new situation, or everything changed, all the code and frameworks that we use changed tomorrow, would you be able to adapt? I think you can tell that when you chat through to people. They can think through failure modes and scenarios where it won't quite work, which is important as well. So you say to them, how would you build, I don't know, how would you build a customer facing chatbot that could, tell me about the company or something? And they might start saying, all the data that's on the website, and have that available for the agent to blah, 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 blah. And then you say, how could it go wrong? And that tells you as well how they've rationalized and thought about it. Because if they're like, oh, I don't really know, they've maybe just thought about the happy path. But engineering and sort of building is not really about the happy path most of the time, unfortunately. It's actually about build for all the ways it could go wrong, all the edge cases. Can the model get confused? Can it fetch the wrong data? What happens if your search breaks? How do you make that reliable? What's your error message going to be to the customer? How do you keep that user experience flowing despite the fact something's not quite went right? Or what happens if things are a bit laggy and slow? Is there fallbacks? And that's maybe getting a bit deeper in it, but I think that's a big thing I look for as well. In juniors, just that kind of, that tells you that they've tried stuff before and they know it doesn't work most of the time. And I think, that just appreciation I always look for between a demo's not the same. I remember I even have, I won't say who, but I had a very kind of respected, amazing colleague before, but it was more in the data science side. Very kind of impressive guy. But I remember him saying, all the production stuff's easy, Andy. You just put it in an app. It just says you put it in a Flask app and you deploy it. And I was like, you've really underbaked that completely. Try it, right? Go try it. This was a few years ago, before Fast API stuff. So that's why it was Flask. I just remember thinking that sort of thing's quite interesting. So it's just that understanding that to go from 0 to 1 can be a long process, or there's many steps to consider. And then the final thing is just being really hungry to learn. Like you said, adaptability and kind of curiosity are the main things now.
I think so.
Can people just keep learning and get in amongst it and roll their sleeves up? A big fan of Barack Obama's phrase, be the person who gets stuff done.
Love it.
If you come at me and you're like, I've got no formal training, I built these 3 things and I did this and I learned this. So you're just like, you can just tell with people they've got a bit of kind of spark about them. You can use that.
Exact same. My line of work as well, 100%. Actually, just a quick story. I was out with someone, just having dinner with them in London after an event last week, and they were talking about somebody they hired into their team. They actually placed them back in 2006. A hire, But the person was talking to me, like, said, I couldn't actually believe this guy was going to join my team and move from London to Bristol. And he just said the impact of this one hire in the business is just like amazing. So I think let's get in that. If you can find these people who are amazing and they've got all those characteristics, and but it's a snowball effect as well because they come on, then
Yes.
they're good managers, they can hire well, and it just builds it all out. I think that's so important.
Yeah, exactly. And it's like to your point, it snowballs and it changes culture.
Yeah.
And that's one thing. The more you're in the game, the more you realize how important culture is.
Mhm.
You have the best engineers in the world, but if they don't know why they're there, working towards the same thing,
Yeah.
they'll be generating lots of fun code, but they won't move the mission along.
Yeah. Totally.
And that's a very different story. Whereas if you can get them rallied around a vision, you'd be like, if we solve this, X, Y, Z is going to happen, and that's amazing. That's an impact on the world, and it's an impact on bottom
Yeah.
line, and it's impact on you. And people get fired up, and they just go get
Yeah.
more done.
Definitely.
And to your point, good attracts good.
Yeah.
I always try and put myself in scenarios where you're going to learn. So you don't want to be. I try and avoid scenarios where I think, oh, I'm the big fish, small pond, or whatever.
Yeah.
I always like to feel imposter syndrome.
Yeah.
People are surprised at this. Andy, you've done really well, blah blah blah.
Mhm.
But imposter syndrome all the time, but to me that's good because that tells me I'm slightly outside my comfort zone and
Yeah.
I'm learning something.
Totally.
Because I'm like, oh, these guys are brilliant. That's what you want. You want to be a bit afraid because you're like, I need to learn to keep up, and that I think is good. So
definitely. Every time I drive to do these podcasts, it's always the same kind of feeling. And once you get started, it's good.
exactly.
And what are the failure modes with agents that most teams haven't thought about yet?
Yeah, I think we kind of touched on some of that earlier, but I think one thing we maybe missed out was the human oversight.
Yeah.
So I think this is one of this. So human in the loop is talked about a lot now. It was with machine learning, but it's really talked about now with agents. Where do you put that step in that involves a human operator to say, maybe pass, go, etc. The challenge I'm seeing is that there's a bit of tension there because you want AI to help you solve problems at scale. The fact you could have an agent that does analysis on 100,000 different issues or pieces of data, you can just scale that up and it can do it. You can't have a human go in and verify those 100,000 pieces of analysis. That doesn't work. So you have to start thinking, what's the sort of methodology you want to apply? What's the operating model? Do you want to just sample some of those and get a human to review? Do you want to have an independent set of AI systems that are coming in and doing the review for you, and then you're just reviewing the reviews? I think this is quite an unsolved problem, actually. This relates to the point about harness engineering. So I'll speak about this more in the book, and I'm working through what I think it all means just now. But there's a real question here about AI can tell us to move at pace, but we have to decouple that from the humans in the loop a little bit.
Yep.
And we have to determine how much we're happy to do that. Because again, in regulated industries and stuff, you can't fully decouple it. Humans ultimately are the ones that kind of, are responsible from a legal, fiduciary, compliance, etc. point of view, right? They have to be. So it can't be low, all hands off the wheel, go for it, agents, have fun. But it's more like, what's your mechanism? What's your harness? How do you trust enough through the evals and the guardrails, but also have humans in the loop where they are needed?
Yeah.
I think that's a really tough one to get right. I don't know the right answer to that one yet, being brutally honest. The good news is there's a lot of technologies and mechanisms that help you do that. A lot of tools are very much human in the loop aware. A lot of the frameworks you use to build agents, they naturally have what we call primitives for that. So they naturally give you the tools and hooks to get humans involved through apps. But again, it's just defining when and how much.
Yeah.
Because you could very easily just do it. You could either not have enough humans in the loop, or you could easily have too much kind of humans in the loop, and then that slows you down. And that's what's happened with the software piece, right? Just now, basically, we have a world where we can generate all the code with software, but we still have humans reviewing every change. So that automatically means it's slower than it could be. So there's a lot of tooling coming online. There's some of it already, but there's more coming online. I'm seeing that's get AI to do the code review.
Yeah.
And then the question becomes, how do you review the big pile of reviews? I don't know the answer, but I think that's a very understated and not fully understood thing yet. That's a sort of failure mode in these systems.
Be good.
So I don't know the answer, but it's a good one to over.
Be good to go back on this in 3 years and ask the same question and see where we're at then. But we'll see where that goes.
3 years, we'll be recording it on Mars.
I know, 12 months. There's loads of responsible AI chat. We spoke about this earlier. That feels like tick boxing. What does it actually mean in practice?
Yeah, so I think responsible AI is quite an overloaded term. The reason they're important is not just because I'm building a system that works, but a system that is compliant and is ethical and conforms to other sort of normative standards I would want to have as an organization or as people. I don't want an agent that acts immorally or tells people how to cheat on their taxes or whatever, obviously, because that's not right in multiple ways. I think those things, and then just thinking that I think to make it real, the key thing is that it is about translating those concerns and those requirements into the engineering problems, the actual real problems on the ground in the system. So we spoke about this before. A lot of organizations have strong opinions on what it means to be responsible, ethical, compliant. The question then becomes to make responsible AI is how do you make your AIs conform to that? And sometimes it is just exposing them to the right information at runtime. So it's maybe just adding stuff to your system prompt and saying you conform to these standards. And Anthropic did this with a constitutional AI approach. So basically, when they're training the Claude models, they give it a constitution at some stage in the process. They basically write down lots of rules, core rules about behavior, and they're like, you internalize this. This is how you behave. This is what it means to be a kind of normal, sensible entity in the world. So, responsible AI is filtered into that ground level from the frontier labs. And then, just when you come to building applications based on this, you have to constantly think, what do we have to layer on top? Because that just saying stuff like telling people how to harm each other is bad. Obviously has to become far more specific when it comes to, say, a bank or a healthcare provider or whatever. It's far more specific. So I think responsible AI, there's a lot of kind of great people out there. I know Paul Donga from NatWest Group, he was speaking at AI Summit London last week. That was super well received. And we're doing a lot in response. I obviously saw a lot of other organizations, but for me, it's that making it real is always about how do you actually translate it to something in your system and not just a nice sort of set of PowerPoint slides.
No, definitely agree. It's a topic. I had a full podcast on this as well. No, it's a big topic.
It's important.
Yeah.
I think it's important.
Definitely.
Yeah, super important.
So you've got like Oxford lectures, you've got your books, conferences, you're doing a lot beyond the day job. What's the strategy here?
Yeah, I think there's always been a thing about you should have a portfolio. And I think it's always been potentially been misunderstood what that means. I think, people think portfolio, I should have 100, it could be 100 articles on Substack or Medium or whatever, but for me, it's always, what do I think about? How can I get my thinking out into the world if people find that valuable in a way that sort of compounds? There's also some selfish elements in that I like writing. I always wanted to be an author. So I'm like, I'll write a book. Always wanted to lecture. So if somebody comes and offers me that, I'll be like, yes, brilliant. So I think there's a combination of that, but it is just about building that portfolio that outlasts any one particular job role I've got. So I've always got something to fall back on. Because as well, when you do a lot of work for specific employers, a lot of it's hidden away naturally. A lot of it's like IP for the business and things you can't share. So it's important to have thinking out there. And again, the portfolio could be a variety of different things. It could be the code you write, open source stuff, could be those Medium articles or Substack. It could be all those things. I've just kind of gone this specific way, but I think anything I can do to say to people, I've got experience I think is useful. Try and learn from it the way I wish I had, just as a positive.
Oh, it's massive
So that's
positive.
what I'm aiming for, really.
I think it's so important for people like yourself to be out there sharing your experience and letting other people know what you're doing as well. Certainly enjoy following you and listening to your stuff as well. And look, one thing you tell a senior tech leader who actually wants to build serious AI capability and not just talk about it.
So I think bringing together those points before, it's like the observability, the evals, the guardrails, I think they're primary concerns, not secondary concerns. They only help by being there, and the overhead for implementing them now is going down all the time. There are tools that you can just get off the shelf. There's open source standards we use for all these things. There's a lot that just builds on traditional software development and engineering. There's a lot there that you can just leverage and do these things. So just don't ignore them. Don't think, oh, they're a bit hard, or maybe I need someone in the team with that sort of experience. Just do it. And build that sort of trust infrastructure, as I call it. So do everything that tells you, how's the system performing? What is it actually doing? Do I trust it before I deploy it? Once you get the plumbing in place for all that, you can only build and build on it. And then you get a really robust solution at the end of the day. We've had this scenario where it's you build something and it works. And then even, oh, that's great. How did it do that? Oh, don't know. or it breaks. And you're like, why did it break? Oh, I don't know. You don't want to get to that point when you've got tons and tons of customers or really high revenue businesses, etc. So I think that's the thing for me, is like invest in those things as primary concerns, not as sort of secondary concerns down the road that you won't regret it. I think it just helps.
Love it. I could keep going for hours here. I was even holding back loads of questions at the end there because I know obviously time and stuff. Brilliant conversation.
I was a bit late.
No, not a problem. As long as all's good with you, no problem with me. I had loads of questions on my head, but we're here to listen to yourself, and that was brilliant, Andy, really. Aye, I'm looking forward to this one getting out. That'll be out soon as well, and I know, just a story, you might not even know this, but I know when you were on Rob's A Boston Data, when he was doing the Boston Data podcast, I can always remember the stats went from there to there, and it just went, we actually got a phone call for somebody who was helping us. So I know you've got a massive following out there. People
Well, that's good.
Oh,
I'm glad it went that way.
Oh, it was a big spike. Actually, someone that helps us actually phoned up and said, "What's kind of going on here?" So I'm looking forward to getting this one out.
Have you got? That's good observability.
Aye, yeah, I know.
Like, there's an issue. You've had too many followers. I always joke if you get, like, on our podcast, oh, we've had a letter from the viewer.
Aye, yeah.
But it's good to get more than one. So if there's a spike going up the way, I'm happy with that. It's good.
Your network's massive as well, but hopefully this will reach a lot of people that might not know you as well. We're like number 3 in South Africa or something, so we're getting there. Before we go, can you let the listeners know where to follow you, how to find you, where to buy your book, your podcast?
Yeah, the best place to find me is on LinkedIn. I'm a bit of a fiend, as I'm called. So that's LinkedIn's the best place. We do have our podcast. I'll maybe give you the kind of link for that. Another thing we're just doing is Matthew Higgs and I, you probably know Matt.
Matt.
Yep. So Matt's a good pal of mine. We've just started a Substack called Forward Deploy.
Nice.
We're going to share that. So we're actually, what we're doing with that is we're trying to take like cool ideas from more academic research and build utilities and frameworks and examples for people to use. So we've got a few posts there about like rubrics-based evals. We're doing some stuff on Bayesian control for agents. All these cool, funky side projects that we're going to stick in there. So I would tell people to follow that. We've got a lot of juicy content coming as well. But yeah, LinkedIn's the main place.
Brilliant, Andy. Big thanks to Andy. His book and his works are linked to the show notes. Go have a look. And if this was useful, send it to someone in your team who's building AI right now. If you're watching YouTube, hit subscribe so the next one finds you. See you next time. Thanks again, Andy. Thanks for listening to A Class Act. If you've enjoyed the episode, make sure to follow the show so you never miss a conversation. And if you're building a data team or making a key leadership hire, reach out to us at MBN Solution using the link in the show notes.